Welcome to Rocket Lab Launch Complex 1, the world's first private orbital launch site. And check out that beautiful clear view over the pad as we count down towards our next Electron launch from Pad A at Launch Complex 1. We are just minutes away from liftoff for our next dedicated mission for the Japan Aerospace Exploration Agency, scheduled today at 3:09 p.m. local time here in New Zealand. Thanks for joining us here at Rocket Lab's Mission Control Centre. My name is Muriel Baker, and alongside Julian Spice, we'll be taking you through today's launch for JAXA and their Kakushin Rising mission.
Thank you very much, Muriel. It's great to be here once again as we count down to liftoff. Today, Electron will be heading to a 540-kilometer circular low Earth orbit on a 97.5-degree inclination, launching on a southern trajectory from Launch Complex 1 over Antarctica. It's the second of two dedicated launches we're flying for JAXA's Innovative Satellite Technology Demonstration Program, a national project to test some bold new ideas and technologies on orbit from companies, universities, and research institutions throughout Japan.
On board Electron today are 8 small satellites ranging from educational Cubesats to an ocean monitoring spacecraft, as well as demonstrations like ultra-small multi-spectral imaging systems and a deployable antenna inspired by origami folding techniques. And today's mission follows our first Electron launch for the program back in December, called Raise and Shine, which deployed another 8 technology demonstrations, instead packed inside one spacecraft called Raise 4. The word Kakushin primarily means innovation, reform, or transformation in English, and it signifies a fundamental or disruptive change in technology or business, which makes it a fitting choice for the Kakushin Rising mission name today. For more on their tech demo program, here is JAXA.
JAXA, Japan Aerospace Exploration Agency, is a national research and development agency that supports Japan's space development and utilization through technology. Its missions range from Earth observation, planetary exploration, and fundamental space science, space transportation, as well as human spaceflight activities aboard the International Space Station. JAXA also promotes collaboration with industry through research on next-generation aircraft technologies and on-orbit demonstrations of innovative space technologies. The Innovative Satellite Technology Demonstration Program is a JAXA initiative that collaborates with private companies and academic institutions to pioneer the future of space development. Through this program, innovative ideas are tested and demonstrated in space, leading to the creation of numerous new technologies. This marks the 4th chapter of the Innovative Satellite Technology Demonstration Program. Raise 4, the 4th small demonstration satellite carrying 8 demonstration-themed components, and 8 CubeSats are now heading into space.
Raise 4, the 4th small demonstration satellite, is designed to demonstrate 8 demonstration-themed components on orbit. Based on requests from the demonstration users, the satellite is operated to provide both experimental data from the component and environmental data during the mission operations. In the Innovative Satellite Technology Demonstration 4, 8 CubeSats are also given the opportunity for space demonstration. Each CubeSat carries a challenging concept aimed at advancing satellite component performance and innovative development methods, which lead to revitalize the space industry and to create new space business models. These demonstrations will help expand the possibilities for future space utilization.
JAXA will continue to take on challenges toward the future of space.
Today's mission will be Electron's 87th overall launch, but only the second time we've launched a dedicated mission for JAXA directly. Together, this pair of missions is taking advantage of Electron's reliability and flexible schedule to deploy to space when, where, and how they need.
Now, speaking of when and where, at T minus 13 minutes and counting on the clock, we are looking good for an on-time liftoff today at 3:09 p.m. local time. And while the weather looks good and operations have so far been trending green for launch, the official call to proceed with the final countdown comes during the Go No-Go poll run by Rocket Lab's launch director from Mission Control. So at T minus 12 minutes, Paula Terrace-Serralonga is scheduled to run a status check across both her team in MCC and in range control at Launch Complex 1.
That is right. Each operator across propulsion, mission management, avionics, weather monitoring, and our global ground station network has to report go for the poll to be cleared to proceed through to liftoff. We're only a few seconds away now from the poll beginning, so let's listen in.
And to all stations LD and Mission Core proceeding with the Go No-Go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
FAN.
FAN is go.
LSO.
LSO is go.
LD sub.
LD sub is go.
Go No-Go sequence is now complete. We are T minus 11 minutes, 17 seconds and counting. We'll go for terminal count auto sequence starting at T minus 10 minutes. From this time, the 3-word procedure is in effect. GC, LD, and mission court.
LD, GC.
GC, proceed with the launch pad ready sequence number 60.
Copy, sequence 60 in work.
Great news out of Mission Control there, and no change to the launch's T0 liftoff time either, which means we are right on track for liftoff today at 3:09 p.m. local time for Kakushin Rising.
Stage 1 igniter pressure verified. Hydraulic pressures verified.
While the countdown continues, let's take a closer look at the rocket making all of this possible. Electron is an 18-metre tall, 2-stage rocket designed for dedicated launches for small satellites like today's mission. That means JAXA and our other customers who fly dedicated have complete control over things like the schedule and orbital trajectory, rather than sharing space on board with other satellite operators. Now, that type of launch option didn't really exist, or it was too expensive for small satellites before Electron came along and started launching in 2017.
At the top of the launch vehicle, we have the payload fairing, which is enclosed over the top of the spacecraft. It's a carbon composite shell designed to protect the payload from intense aerodynamic, thermal, and acoustic loads that are experienced on a rocket while launching to space. Inside that fairing, Kakushin is attached to a small, specialized platform called the Kickstage, which we use once we're in space to deploy satellites to their specific orbit after it separates from Electron's second stage. With its 3D printed Curie engine, the Kickstage can perform multiple burns to adjust its inclination and reposition a satellite before it's released, and to finally perform its own orbit-lowering burn that brings it closer to Earth to deorbit quicker and minimize space debris.
Now, below the payload end of the rocket are Electron's second and first stages, each fueled with liquid oxygen and kerosene to power their own sets of Rutherford engines. Now, stage 2 contains a single Rutherford engine, while stage 1 holds 9 engines to generate enough thrust to power Electron most of the way to space. Each one of those engines are 3D printed, and they're also unique in the industry for being electrically driven, using battery-powered pumps rather than traditional gas generator turbo pumps. That design makes the Rutherford more efficient for mass manufacturing, which, along with Electron's flight history and satellite deployment accuracy, are some of the key reasons why Electron is the world's most frequently launched small orbital rocket.
Our heritage in propulsion is one we're particularly proud of here at Rocket Lab. As well as the Rutherford and Curie engines used on Electron, we've also created a significantly larger and more powerful rocket engine called Archimedes, designed for our much larger, different class of rocket, Neutron. Just to give you a sense of scale, Archimedes has roughly 35 times the thrust of a Rutherford engine, while a single Archimedes is equivalent to more than 3 entire Electron rockets.
Now, on the other end of that spectrum is our newly introduced electric propulsion system for satellites called Gauss. And it's made for long-duration missions in space and high-performance maneuvering aimed at new satellite constellations. These types of thrusters are hard to find or to bulk order in the satellite industry, but with Gauss firing away and a production line already set up at our facilities, that is something we're looking to change. Here's more about Gauss.
Gauss opens a new chapter in propulsion at Rocket Lab, but it really is a natural extension. And electric propulsion is an important tool to have in the kit. Propulsion is in our DNA. I think Rocket Lab has one of the best propulsion teams in the entire world, and it's really exciting to see it expand into electric propulsion. Gauss is an electric propulsion system based on a Hall effect thruster that's designed to do orbit raising and deorbit, as well as on-orbit station keeping for constellations. So there have been a lot of bottlenecks in the supply chain for constellation programs, whether it's commercial or national security, and one of the biggest has been electric propulsion. We experienced that in many of our programs, and so we decided to insource and solve the problem ourselves. So Gauss is a really good thruster in its class, and so it's about a 700 to 850 watt thruster that's got about 40 millinewtons thrust performance and excellent specific impulse. But what's great about it is that it's also throttleable, so that you don't have to size your power system to the propulsion, but rather you can have the propulsion work to your power system. Even though we've qualified it for xenon, we of course recognize that there's other gases that people want to fly. So Gauss was designed with that in mind as well. Like Pete has said about our rockets, the first rocket's the easy one. It's the 10th one that's hard, and we've established high volume production capacity to deliver units now. Rocket Lab's initial production capacity is about 200 units per year, and that includes the Hall effect thruster itself, as well as the flow control and the high voltage power and processing unit avionics that drive the system. And so because Rocket Lab produces the Gauss system in New Zealand, it is actually subject to no U.S. export restrictions. And so this is a really important factor that particularly international customers are going to consider when they make their electric propulsion selections. It's a really exciting moment for Rocket Lab. We've started to deliver units to ourselves. And so right in this factory, we have satellites being integrated with our Gauss thrusters and available for the market today.
With the introduction of our Gauss thruster, we are continuing to alleviate the pain points of satellite production.
We're now just inside 4 minutes to launch, and everything that you're seeing here is about to become fully automated for the final countdown before liftoff. Electron's onboard computers will take control of the terminal count from T-minus 2 minutes, and will begin to manage thousands of checks per second to make sure Electron is ready for launch. At that point in the countdown, both stages will also be fully fueled with liquid oxygen and kerosene. The propellant tanks are being kept at precise pressure and temperature before we reach liftoff, and you'll hear a couple of callouts from operators in mission control that relate to those checks as well. You'll also notice some venting from Electron while that countdown continues, which is completely normal up until the system is fully pressed for flight within a minute of liftoff.
Then from 20 seconds and counting, final checks are complete. The launch director will count down to launch from T-minus 10 seconds, and then at T-minus 2 seconds, Electron's engines will ignite right on time for liftoff at T0. We're going to raise the volume now on mission control and listen into all of that take place. Go Kakushin Rising, go JAXA, and go Electron.
Beacon, lock the auto sequence and confirm.
Locked.
Copy and confirm all flight computer ASGOs are green.
All flight computer ASGOs are green.
Copy, Beacon. We'll go for auto sequence start at T-minus 2 minutes. LDs go for launch.
Vehicle is fully on internal power. AFTS is green and enabled for flight.
LOX load is complete. The system is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lift.
Vehicle is going to pass. Safe launch path. Beginning pitch over.
Stage 1 propulsion is nominal.
Liftoff confirmed, and Kakushin is rising with Electron from Launch Complex 1. We are on our way to orbit for JAXA, and pitchover has begun to place the launch vehicle on its correct trajectory south over Antarctica.
We're building up horizontal velocity now before Electron is expected to pass through max Q, or maximum aerodynamic pressure, We should hear a call out from mission control that we've cleared it momentarily.
Cleared max Q.
And there's the call out for max Q. Those 9 Rutherford engines have accelerated Electron past 2,200 kilometers an hour and more than 18 kilometers above Earth, now just a minute and 30 seconds after liftoff. Next up for the rocket will be main engine cutoff, otherwise known as MECO.
With Electron's boost through Earth's atmosphere almost complete, the first stage's role in this mission is wrapping up since the engines have chewed through most of their fuel supply. The Rutherford engines will soon shut down completely, which will allow the rocket's second stage to separate. With a bit of distance between them, the second stage's sole Rutherford engine will then ignite to carry on the mission's momentum to orbit. And those events occur as MECO, stage separation, and second stage engine startup, all of which we can expect to hear from our operators again soon in Mission Control.
"15 seconds to staging."
Enter it burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
Beautiful work. That is MECO, stage sep and second stage engine ignition as expected as Kakushin Rising continues on to orbit. And in just a few seconds, Electron's payload fairing will split and fall away in two halves. That will be the first time that Kakushin Rising will be exposed to space.
Fairing separation confirmed.
A nice clean payload fairing jettison there, and another Electron launch milestone complete. Electron's second stage is cruising along nicely at more than 8,700 kilometers an hour, now 125 kilometers above Earth on its way to its 540 kilometer circular orbit. We have a few minutes until our next event for Electron, which is battery hot swap maneuver that takes place for the Stage 2 Rutherford engine. That's scheduled to happen at approximately 6.5 minutes into this mission.
Electron's second stage engine burn continues nominally for Kakushin Rising, with this phase of the mission focused entirely on building orbital velocity before those satellites are released. Guidance systems are steering Electron with precision toward the mission's 540-kilometer target orbit. All right, our mission control operators are closely monitoring the vehicle's performance in the lead up to the second stage's battery hot swap event. So the Rutherford engine relies on batteries to drive its electric propellant pumps. But as the second stage burns through the original battery's power, it must transition to a fresh set of batteries mid-flight to keep the engine burning to full duration. And that's why the maneuver is called the battery hot swap, since it takes place right in the middle of that propulsion phase.
The old batteries will be jettisoned, which you should be able to see in real time on your screen. Just watch for the silver box to eject quickly, right at around the T plus 6 minute 33 second mark. Just a couple of seconds to go until that happens.
HVV discharge holding nominal, approaching a hot swap in roughly 30 seconds.
Throttling down.
battery jettison confirmed.
Hot swap successful.
Stage 2 propulsion holding nominal.
Battery hot swap confirmed, and the second stage is powering on beautifully for JAXA and Kakushin Rising. We got another 2 minutes or so of Rutherford engine burn time to get us to the mission's transfer orbit, and at this point in the flight, Electron's second stage has completed almost all of its mission milestones.
The last remaining steps are second stage engine shutdown and then separation of the Kickstage with its satellites, much like what was experienced for stage 1 and stage 2 separation. And we are less than 2 minutes away from the second stage's final actions.
HUB discharge holding nominal.
Electron is powering through 1,900 kilometers an hour and rising, passing through 204 kilometers in altitude on its way to JAXA's final orbital altitude of 540 kilometers. Before we get to that, though, the second stage will deliver the Kickstage and its payload to what's called a transfer orbit. This is an intermediate elliptical trajectory that's used to move the spacecraft into its final circular one. It acts like a bridge, with the Kickstage using its engine to expand that transfer path and enter the final orbit for the mission.
Okay, time is almost up now for Electron's second stage engine burn, and what will happen next is this. That Rutherford engine on your screen will be shut down by the rocket's flight computer, which will cause the nozzle to go from red hot to grey and cold. And within seconds of that shutdown, the Kickstage will be separated from the second stage and released into its transfer orbit for the mission. Standing by now with Mission Control.
Seeker confirmed.
Stage separation confirmed.
Nominal transfer orbit achieved.
There we go. That is SECO confirmed with the Rutherford engine shut down and the Kickstage released from the second stage. Kakushin Rising is almost ready to be deployed to space to begin its mission. Once the Kickstage completes its transfer orbit, it will ignite its engine to move out of that elliptical trajectory and into a circular one before the satellites are released.
Completing that elliptical path around Earth takes about 40 minutes or so, and so we'll be taking a break from the broadcast during that coast phase, but we will join you again live just before payload deployment of Kakushin Rising, which is scheduled to start at T plus 50 minutes into the mission. We'll see you back here then. Hello and welcome back to our broadcast for the 87th Electron launch, the Kakushin Rising mission for JAXA. At 3:09 p.m. local time today, Electron left Earth with a beautiful looking launch from Launch Complex 1. After completing all of the usual milestones on the way to space, Electron separated its Kickstage with JAXA satellites to a temporary orbit around Earth.
After entering our transfer orbit 40 or so minutes ago, the Kickstage is now ready to ignite its Curie engine to circularize to 540 kilometers. Let's go ahead and listen in.
Curie ignition confirmed.
And we just heard it there from Mission Control. Curie ignition is confirmed. This burn will last about a minute and a half, and then it's showtime for the payloads of Kakushin Rising. The payloads will be deployed at various intervals, and sometimes together, across the 3 minutes following Curie shutdown.
And if you've ever wondered what a Curie nozzle looks like, well, today is your lucky day because we have one here to show you. It's only 15 centimeters tall, but it packs quite the punch. And it's named after Polish-born French physicist Marie Curie, and it's responsible for our highly accurate payload deployment. Now, the Curie engine has a specific impulse of around 320 seconds, and like our other liquid propellant engines, it's majority 3D printed.
You may have picked up on a theme of our engine names. They're all named after groundbreaking physicists. Ernest Rutherford, Marie Curie, Archimedes of Syracuse, and now with our new ion thruster, we could add Carl Friedrich Gauss to the theme.
Otherwise, we are coming up on Curie cutoff very soon, so let's listen back in with Mission Control.
Curie cutoff confirmed.
Nominal final orbit achieved.
There we go, straight from Mission Control, Curie cutoff confirmed. The first payload out will be FSI-SAT-2, a 1U Cubesat developed by the Future Science Institute as a low-cost satellite featuring a multi-spectral camera and onboard data processing system.
FSI-SAT-2 confirmed.
To space, FSI-SAT-2.
Next up will be COSEN-2R, a 2U satellite developed between the National Institute of Technology, Yonago College, Gunma College, and other educational bodies. And it features a deployable antenna that will extend to study deformation of the Earth's crust below the sea floor. Let's listen in.
COSEN-2R, payload separation confirmed.
Nice one. That is COSEN-2R deployed to orbit to begin its mission.
Next up is a spacecraft called PRELUDE by Nihon University, a 6U nanosatellite created to detect earthquake precursors from space using VLF radio waves. Let's go, PRELUDE.
Payload PRELUDE separation confirmed.
Congratulations to the Nihon University team and JAXA, and welcome to orbit.
All right, two at once up next. The fourth payload is MONO-NIKKO, developed by Dai-Nikko Engineering Company, and it's an on-orbit demonstration of an intelligent power unit that can acquire status data from batteries installed on ultra-small spacecraft. And then payload number 5 is Magnaro 2 by Nagoya University. And their mission is to test a new method for constellation formations that involves rotating and separating linked microsatellites.
Payload MONO-NIKKO and Magnaro 2 separation confirmed.
5 out of 8 at their new homes. Welcome to space, MONO-NIKKO and Magnaro 2.
It's time for the final deployment for the final 3 spacecraft. First up is Arika 2 by Aoyama Gakuin University, testing a SATCOM network as an alert system for astronomical objects. Then we got Waseda Sat-02 by Waseda University, who used a molding technique to create their spacecraft with no screws or mechanical parts. And lastly, the Origami Sat-2 by the Institute of Science Tokyo. They'll be testing a lightweight and highly compact deployable antenna that's packed away using origami techniques, making it 25 times smaller when stowed.
Payload Origami Sat, Payload WSZ2, and Payload Arika 2 separation confirmed.
Outstanding results there for JAXA's Kakushin Rising mission. Welcome to orbit, Arika 2, Waseda Sat-02, and Origami Sat-2. A marathon deployment there from Electron's Kickstage. Just want to say congratulations to JAXA and all of its project partners for this latest mission of its innovative satellite technology demonstration program.
That is our second dedicated launch for JAXA, complete on Electron with 100% mission success. A proud moment for the team to support such an exciting mission full of interesting new technology. And that is also launch number 87 complete for Electron. So our next launch will be at the pad soon. Keep an eye out on our website and social media channels for details of those missions coming up. Otherwise, thank you so much for tuning into today's broadcast. Until next time, this is Rocket Lab Mission Control signing off.